In this video, we're going to be talking about quadratic simultaneous equations. So you need to be able to solve simultaneous equations where one equation is linear and one is quadratic. And we looked at linear simultaneous equations in the previous video, so if you haven't checked out that one, I would do so now. To solve simultaneous equations involving one linear equation and one quadratic equation, you need to use substitution. Okay, so let's write this down. And again, I looked at the difference between substitution and elimination in the previous video. So simultaneous equations with one linear and one quadratic equation can have up to two pairs of solutions, and you need to make sure the solutions are paired correctly. So let's have a look at what I mean by looking at an example. So we're going to have one linear equation, which is going to be x plus 2y is equal to 3. And then we're going to have one quadratic expression, x squared plus 3xy is going to be equal to 10. Okay? So the first thing that we want to do is that we want to rearrange the linear equation to get x equals or y equals something. So we want to get an expression of x or y by itself so that we can substitute that into our other equation. So here it looks quite easy to get x by itself, because if we take 2y from both sides, we're going to get x equals 3 minus 2y. And from there, all we really need to do is plug 3 minus 2y into our second equation here together. So that is the whole process of substitution. We are substituting x equals 3 minus 2y into this one. So let's do that now. We've got 3 minus 2y squared plus 3, and then 3 minus 2y, y equals 10. So we've replaced the x with that expression for x. And then all we want to do now is expand this whole equation here. So 3 minus 2y squared is the same as going 3 minus 2y, 3 minus 2y, like such. And we've got 3 times 3 is 9. 3 times minus 2y is minus 6y. 3 minus 2y is minus 6y. And minus 2y times minus 2y is positive because we're multiplying two negatives. 2 times 2 is 4, y times y is y squared. So let's first of all write that out. We've got 9 minus 6 is minus 12y plus 4y squared. That's the first aspect. And then the second aspect is this bit in the middle here. So we've got 3 times 3 minus 2y times y. And that's simply 3 times 3. Well, let's write this over here. We've got 3 times 3 is 6. And then that's also multiplied by y. And we've got 3 minus 2y is minus 6y plus y times y, is squared. So we've got negative 6y. Sorry, I've been very silly. 3 times 3 is obviously 9. Some basic math there. Make sure you don't make that same mistake as me. And we've got negative 6y squared. So let's just plug that into here. We've got plus 9y, negative 6y squared, and that is equal to 10. And so all we then want to do is we're sort of getting a familiar sort of expression here. We want to change this into a set quadratic expression. So if we collect our y squared, we've got 4y squared minus 6y squared, which will give us negative 2y squared. And then we're going to have to collect our y term. So we've got 9 minus 12. So that gives us negative 3y. And then finally we want to collect our 10 here. So, and also our 9. So we're going to get our 9, and then we're going to take 10, because obviously this, if we take 10 from both sides, that'll give us negative 10 equals 0. So minus 10 plus 9 equals negative 1, which is equal to 0. And then what I quite like to do at this point is just to make it all positive, or at least get our coefficient of y to be positive, but as it's all negative, we can add 2y squared and add 3y and add 1 to both sides to give us 2y squared plus 3y plus 1 equals 0. So now we've got a quadratic expression, we now want to solve this expression. So let's just keep that at the bottom here and let's continue with our sum. So we've got down the bottom here 2y squared plus 3y plus 1 equals 0. And to solve this, we want to find a number that, or two numbers that multiply together, you can't see that, that multiply together to make 2 and add together to make 3. So what do you think that could be? Well, I'm thinking 2 and 1, because if we add 2 and 1, we're going to get 3. If we multiply them together, we're going to get 2. So let's rewrite this expression, this equation, with our new figures for y. So we've got 2y squared plus 2y plus y plus 1 equals 0. And then we're going to focus on each half of our equation by factorising them down. So we've got 2y squared plus 2y. 2y goes into both sides. And then we've got an extra y here to make it 2y squared, and then plus 1. And then we've got y plus 1, so we're just going to put a little 1 here, because nothing can go into y plus 1. And then obviously y plus 1 to make sure that we multiply them out to get our y plus 1 expression. And then this is the same as saying 2y plus 1, y plus 1 equals 0. And so we get we're going to get two results for y now, okay? Obviously we want to equate y plus 1 equals 0, and we want to equate 2y plus 1 equals 0, which means that y is either going to equal -1, so if we take 1 from both sides, we're going to get -1, or y is going to equal, or if we take 1 from both sides, it's going to give us 2y equals -1, and then we can divide that by 2, so that's going to be -1/2. So now at this point, we want to find the corresponding values of x by substituting the y values into our linear expression. So remember, at the very beginning, we had our linear expression, which was x equals 3 minus 2y. So, or as I think I originally wrote it, I think I put x plus 2y equals 3. But this is our original expression here. We isolated our x value after we wrote that. So we've isolated our x value, and now we can just plug in our values of y into this equation. So our first one would be x equals 3 minus 2 times -1, which is going to be x equals 3 minus 2 times -1 is going to be plus 2. So we're going to have 3 plus 2. So that's going to be equal 5. And remember, this corresponds to our value of -1. So down here, we can say that x equals 5, y equals -1. So that's our first sort of group, our first group of solutions. And remember, you've got to make sure that you group together the right x value, the right y value. Otherwise, you're going to get the wrong answer. And our second one is x equals 3 minus 2 to the -1/2, okay? And if you plug that into your equation, you're going to get -2 times -1/2 is 1. So -2 times -1/2 is going to halve it, so -1, and change the sign to make it +1. So that equals 3 plus 1, which is equal to 4. And so therefore, as a result, we can say that x is equal to 4 and y is equal to a -1/2. And then that will give us our two solutions. There are two solution pairs for both x and y. And that is how we can solve a quadratic simultaneous equation.